Already. Perfect. Well, thank you for doing this, Charles. We really appreciate your time, and kudos to whole your team that set this up. They were really nice to work with. You got really nice people around you. We have, of course, some questions for you that we sent your team, and we've been talking about. And we know that we're not going to talk about price or anything like that in this discussion, even though we got a lot of questions in regards to that for some reason.
Yeah, it's almost like
But
it
I
hit
thought,
$3 or something like that. Go figure.
yeah, exactly. I don't know why, but yeah, people are really interested in the price. But I thought we'll start off because we have a lot of new people coming to our platform that are new to crypto, and they might actually buy Cardano or any other cryptocurrency that we have on our platform for the first time, and they might not know a lot of what they're actually buying, etc. So I thought we'll just start off with some personal questions. So I would like to ask you, maybe this is a hard question, I don't know, but who is Charles, and how did you get into this space?
Well, talking about myself is always an interesting one. So the reality was that I'm kind of the accidental entrepreneur. I never really expected to be a cryptocurrency entrepreneur, much less a CEO of a company. Really, I just had a lot of passions and interests that were quite divergent from the mainstream. And then when Bitcoin came around, those passions and interests were placated. So, for example, I liked Austrian economics, and I like sound money and firm monetary policy and these types of things. Well, that's great, but no central bank in the world follows Austrian economics. No government in the world follows Austrian economics. So, unless you become like an economist at some backwater university, you're not really going to get any love there. And I really enjoy the cypherpunk movement and the open source software movement. We call it the FLOSS, the Free Libre open source software movement. And I really like cryptography and mathematics. So Bitcoin came around, and it was kind of a roll up of all of these things. It had math and computer science and open source ethos and all these cool things that we've been talking about in the cypherpunk movement since the 80s. And then also it added on top of it a monetary philosophy that was very vogue. So it felt like the perfect thing to belong to. But I didn't know anybody, and I didn't know what to do. And so I said, well, I have a mathematical background, so what I can do is teach. There we go. So I created the Bitcoin Education Project, and I released a free class on Udemy, still around there, and it has over 80,000 students, and I got over 5,000 emails. I answered every single one of them. I've worked real hard on that. And that gave me an opportunity to meet everybody in the industry. And more importantly, one of my students actually was a venture capitalist. And so he contacted me and said, hey, I'd like to give you some money to start a business. And I was like, oh yeah, sure. You got some land you want to sell me too, right? I didn't really believe him. But he, sure enough, was a real guy, and he gave me $500,000 to start a venture. And then from there, I started a series of ventures of building up to IO Global. And what we're due here at IO Global is kind of the dream job. I said, well, if I'm going to keep doing this, I should enjoy what I do every day. So we're both a research and a development company, and we sell systems. And so on the research side, we actually integrated ourselves in the academic politics. So we're at University of Wyoming and University of Edinburgh, University of Athens, and Tokyo Tech, and we have all these other affiliates. And we basically write papers. We've written over 100. And then on the engineering side, we build blockchain-based systems, and we try to get those systems into governments, into corporations, and also make them publicly available for people to build on top of them. And we've grown from 2 people to over 500. I've been to 52 countries since we started this. It's been a pretty remarkable growth curve.
Oh, wow.
I'm going to shut my door.
You said you were, oh, no worries. 500 people, that's a lot. I had no clue about how big they were in size of employees. So you said 500 people. That's a lot.
Yeah, it's grown a lot.
Yeah. Well, I know who you are, and I've been following you for a couple of years. But one thing that I have no clue about is I mean, this might be an even harder question to answer. I have no idea, but it's the lobster. What's up with the lobster? I heard that the lobster is getting its own NFT as well.
Oh my God, this lobster is growing by gangbusters. It's almost growing as fast as Cardano is. So I wanted to do a social experiment where I said I had this lobster that was just stuffed lobster that I got for a completely unrelated matter. And I said, well, it'd be really cool if we could just, put the lobster on the microphone, because it was sitting literally right here on my desk. And then let's just see what happens. Let's see if people notice it, people talk about it. So a lot of people started noticing it. A lot of people started talking about it. They kept asking, well, what's the name of the lobster? I said, well, why don't you guys name it? I've gotten over 197 names now from the
Wow.
community for the lobster. So from Krusty the Crustacean to Mike on Mike, to Shelby, to Ralph, to Big Red, Claudano. There's a lot of creativity that the community has. And now I also have people who are graphic novelists that are saying, hey, we could actually create an entire backstory and create a graphic novel for the entire lobster. And then if that happens, we'll create an NFT for the lobster. And then it's just a great case study where this new economy, there's infinite possibilities there. You can literally just take a stuffed animal and put it on your microphone and wake up a year later and have a multi-million-dollar product. So it's a completely new way of thinking about the world.
A multi-million-dollar lobster. Yeah,
Well, once
that's
I have
interesting,
lobster money,
actually.
Lucas, I can retire. I can just go do
Exactly.
other things.
Exactly. Well, I was listening to your Saturday night thoughts there the other day, and it sounded like there was a bit frustration with the market and how people are acting. And my colleague told me that you are doing a lot of paintings. I was wondering, after that broadcast, did you go and do some painting to relax your nerves, or
I've been
is
trying
that
to get
something
it.
you do?
Yeah, I've been trying to get into painting. I really have, but I just have not had the time. So I first said, well, I'm going to learn how to draw first, then I'm going to paint. So then I can sketch what I want to do, and then I can paint from those sketches. So I did take a drawing class, and I also got the entire series for Bob Ross on how he does these wet paintings. And
Oh,
I've never really mastered anything that I can show off to the community yet. However, 2022, that is going to be a big priority of mine. So I'm definitely going to paint, and as our NFT marketplace improves, then I'll actually sell the paintings as NFTs, and we'll see what they do. I'll probably donate all the proceeds to charity or something like that. But in general, I mean, just this art form of shutting off, being in flow, and trying to focus in on producing something, either something in your mind or from a picture that you see, is so therapeutic. And every study, time after again, has shown that painting can be tremendously helpful for people working through things, both during and after the event. Like, for example, George Bush paints, President Eisenhower painted in the Oval Office. There's been a lot of people throughout history who have used that as a proper refuge.
Yeah, like creativity in general, I guess. So now we know who Charles is. We know about the lobster and the paintings and NFTs. That's most likely coming from Charles. I thought, as we have a lot of newcomers to this platform, I thought we'll just take a step back and look at what is a blockchain, and why is this important to us today?
So really, a blockchain does three things for you. It's a place that you can put a piece of history that's time stamped. So when it's put in, timestamp it. There's a date on it. It's immutable, so you can't change it, and it's auditable. So some group of people are able to look at that and verify that record through some mechanism. So those three properties are very powerful when you think about a lot of commercial systems. Like, when did you sign the contract? Who signed the contract? You have identity, supply chains. When did it come into port? When did it leave port? Medical records. When did the doctor see you? Is there a prescription? These types of things. Is it a legitimate prescription? The academic industry. You have a diploma. When did you get it? Is it a valid diploma? Did you actually take this class? Voting. You say, okay, when did you vote? Who did you vote for? How do you audit the vote? How do you make sure the vote hasn't been changed? Or money. How much money do you have? How do I know you have it? How do I make sure that you haven't sent the same money to two different people, and so forth? Generally speaking, how we accomplish these problems, solve these problems in the traditional sense, has been using a centralized database. That's perfectly fine as long as you trust the database. So the issue is that a lot of these problems, from medical records to voting to healthcare to money, the central actors who run them haven't either done the best of jobs, or they've done it at outrageous expense to society. So very expensive to send a wire transfer, very expensive to use Western Union, or in the United States, a lot of people think the voting system has problems. So a lot of little things like that. So blockchain came around and it said, okay, you can do all those things, but you can do those things as a decentralized service instead of centralized, meaning there's nobody in charge. Somehow, some way, the system is able to advance and operate, but no central entity is able to stop the system or is responsible for curating it. Well, what makes that so special is that that means the system is really resilient, and then also the system is highly likely to follow its original intent in programming. No one actor, the US government or China or whatever, can come in and say, well, it's inconvenient to us. Go ahead and change the system for us. No, it just runs as it was programmed. So Bitcoin, for example, there will only ever be 21 million Bitcoin. Okay, so the system is built that way. There's no way to change it. Even if Satoshi Nakamoto came out of hiding or from back from the grave, wherever the heck that person is, and said, let's go to 22 million. Couldn't pull that off. It just wouldn't change. So that's really the beauty of blockchain in that respect. And there's a whole science behind whether a small group of actors can control the ledger or it's permissionless. So permission versus permissionless, the level of auditability, the types of transactions that can go into that system. So that's you'll hear a lot like smart contracts versus non-smart contracts, and also what types of assets can live there, and also metadata and identity. And these are all nuances, and that's why there's over 8,000 different blockchains that are in production right now in the industry, because there's not a consensus of opinion about which solutions are useful and which ones are not. And our industry is going through kind of a Cambrian explosion of life. And at some point, there'll be a great extinction, and we'll consolidate down to a collection of technologies. Not hard to say how many. And those will become the backbone, in our view, of the global economy in the next 20 or 30 years for pretty much everything.
So one thing that I've been thinking about when it comes to this is, all of this sounds like some sort of alien technology just landed upon us, and we have to deal with it, and understand what we can do with it. But how much does the general public need to know? How much do you need to actually understand? Or do you think this will just change over the generation, that you will understand more and more as you learn this in school or whatever? Do you think, how much does actually one need to know?
Well, great technology doesn't require you to understand how the technology works in order to use it. So if you use a gun, you don't have to know how a gun works, or use electricity. When you flip the light switch, you don't have to know how electricity is generated and transmitted. It's the same for a cell phone. To make a call on your iPhone, you don't need to know how the iPhone works or how a touchscreen works or 4G works or any of these types of things. So similarly, if blockchain is to be real, it has to fade into the back, and great consumer experiences have to be built on top of it. And really what it is it's infrastructure. So it's not the concern of the mainstream. It's the concern of the product makers and the entrepreneurs, the UI UX people, to figure out how to make this technology mainstream. And usually it's related to a problem domain. So for example, you're in Kenya, you pay 6% per month right now for a loan for your business, and you'd like to pay 1%. Well, the solution for that probably will involve a blockchain at the end of the day, because you're removing middlemen, so you're reducing the overall cost of servicing the loan. Or maybe you are Norwegian and you travel to Spain and you get very sick, and your doctor in Spain needs to see your medical records from Norway. How do they get transmitted from Norway to Spain? The solution of that problem could involve a blockchain as the access control system to enable that transfer in a trustless way. Or maybe you're a web developer and you're creating a website and you want to replace your username and password with decentralized identifiers. It's a type of ID that's blockchain based for the most part. And so you can get rid of passwords and usernames and have a much more secure login experience for your users, and because people tend to reuse the same password everywhere, these types of things. So these are examples of real life problems. And really what blockchain is offering is just like Ruby on Rails, or just like Meteor, or just like React, or any other framework, a collection of tools that you can use. And with any solution, there's going to be probably some centralized components. But now, for the first time, as a developer, as a business owner, you could add decentralized components as well. And it's not academic. I mean, look at OnlyFans, for example. They just announced, hey, we're not going to do pornography anymore. That's $2 billion of money that just got shut off. Well, what happened was that their payment processors came to them and said, yeah, we don't want you to do that anymore. So they said, great, okay, so we're going to have to throw away like 80% of our business as a company, or else we go out of business, and somehow try to find a way to survive without that. So really hard, when you have bad systems to compete in a global economy. Really easy to compete in a global economy when you do. When the internet came out, suddenly we all got to know each other. We could talk to each other. We could send information instantaneously, and that disrupted every type of business. So now our industry is all about the movement of value instantaneously, the movement of identity instantaneously, the movement of commercial arrangements instantaneously, anywhere in the world, without necessarily trusting people in the process of doing that. And of course, just like the internet, it's going to be vastly disruptive on business. It's going to create a lot of new economic activity. But as for the mainstream consumer, what's going to happen is you'll have gateways like browsers and cell phones and these things that basically beam you into that world. And you don't really have to know how that world works for it to be useful to you. You're just a beneficiary of the things that it does.
Hmm. So where do we see Cardano in all of this? What was the vision back in 2015, I believe, when it started? And do you think that vision or that goalpost has changed over the year, or is it still the same?
It's always been the same. So the easiest way of explaining Cardano is to start from the beginning. So Bitcoin was the first generation of cryptocurrencies, and really the only problem it was trying to solve was decentralized movement of value, the movement of money. So you have this thing called a Bitcoin. It's an instrument of value, and you'd like to be able to teleport it anywhere in the world, kind of like email for money. Just click a button and boom, it arrives. And you don't trust anybody, so there's no central authority, and it's self-sustaining. All right. So that was kind of a crazy idea because so many things had to work for that to work. You had to get a network effect. You had to get miners to secure the network. You had to get lots of people to install the software without any money or centralized coordination. So it was totally volunteer in the beginning. Exchanges had to form to trade Bitcoin for US dollars. I remember the early days when Bitcoin was less than $1. We'd trade them on spreadsheets on the forums. There was a StarCraft tournament where the fifth prize was the consolation prize was 25 Bitcoin. The fourth prize, I think, was $25. So it just gives you a sense of like where we started. But then in 2013, Bitcoin became worth something, and then suddenly everybody said, "Wow, this is really interesting." But then they realized the limitations of the system. You can only do one thing. You can only push Bitcoin around. You can't issue your own currencies. There's no programmability. It's kind of like the internet when you had the web browser without JavaScript. So you could build these beautiful static websites. So there'd be like pictures and nice text and things like that. But you couldn't do Facebook. You couldn't do YouTube. You couldn't do e-commerce. You needed programmability in the browser. And so that's exactly what we did. We took a programming language, in this case, Solidity, and the EVM idea, put it into Ethereum, and that became the second generation of cryptocurrencies, the whole smart contract revolution. And then suddenly you see all these word salads. You see ICOs and STOs and NFTs and DeFi, and all that stuff was enabled by programmability. The problem is those things currently don't operate at scale. So when you want to stretch it out from just a few people to millions of people or billions of people, it doesn't sustain. Second, there's an interoperability issue where there's just too many of these things going around. So the standards of how do you move information, value, and people between systems have not set. So there's an interoperability problem. The easiest way of understanding that is imagine a world where Wi-Fi was proprietary to the manufacturer. Well, if that was the case, then your Samsung phone would only work with a Samsung router. Your iPhone would only work with an Apple router. Could you imagine how bad it would be at the hotel? You'd fly in and I'm saying, "Oh, I'm sorry, we only have a Google router here, so your iPhone can't connect." That's basically where we're at in the cryptocurrency space. Wi-Fi wouldn't work if that was the case. Well, crypto has to overcome the interoperability problem. And then finally, you have the sustainability problem, which is really broken down into two parts. One part is the who pays, and the other part is the who decides. So these systems, if they're decentralized, they're not supposed to have leaders, but they need to upgrade. And there needs to be developers, and there needs to be money invested into their growth and development. So you have to create some sort of decentralized treasury mechanic and a decentralized government that allows you as a holder of the asset to have some influence and vote on upgrades. Or else what will happen is the system will stagnate, and then it'll only be useful for a small period of time, and then a competitor will come in and replace it. It's like having only Windows 95, and you can't make Windows 98. You can't make Windows XP and so forth. You have to be able to upgrade, or else your product, no matter how big your monopoly is, will die as Microsoft learned. So we term those three things together: sustainability, interoperability, and scalability as the third generation of cryptocurrencies. And it's kind of the replacement of the smart contracting systems and Bitcoin. And there's a lot of contenders. There's Solana and Polkadot and EOS and Tezos and Algorand and Hashgraph. And of course, Cardano is in that set, as is Ethereum 2 in that set as they move to the next generation. So what we did is we started with a collection of principles. We said, all right, we're not going to have any preconceived notions. We're just going to go where the science takes us. We kind of know the design space: scalability, interoperability, and sustainability. And the question is, how do we get there? So we went and spent 2 years writing all these academic papers. We went through the traditional peer review process. It was very hard, and we learned a huge amount. And then we started actually developing protocols from there, like Ouroboros for the scalability side, and then the Catalyst protocols that we developed for voting for the sustainability side. And we built a whole treasury system and Hard-fork Combinator and these things. And then for interoperability, we developed all these primitives like NBX and sidechains and so forth. So in the process of several years of research, we were able to build up basically a good corpus of what the product should look like. And in 2017, we released the first version, and we've been systematically testing, tuning, growing, and updating. And when we launched, we didn't have a lot of people, and now we have millions of people, and we're the #3 cryptocurrency. We keep growing, and what's great is the community is so strong, and we have a huge development ecosystem as well. There's more than 12 firms, I think, that work every day on the infrastructure of Cardano. There are thousands of developers that have gone through the Plutus Pioneers program, and we're just about to launch smart contracts September 12th. So there's going to be tons of applications that start turning on Cardano, and pretty vibrant ecosystem. On the governance side, we have over $1 billion of ADA that's in the decentralized treasury under the control of the community. The people access it through voting rounds. We call them funds. The last fund was $2 million. And there were over 33,000 people, unique people, that participated in that and gave away money to 54 ventures. And a total of 154 have been funded since we started Catalyst. And the next round is just about to begin with 4 million. So we got a decentralized VC in the sky that's building up and bootstrapping the ecosystem. We got a lot of developer vibrancy and a lot of really good technology. And it's been fun because we've kept our principles along the way. On the engineering side, formal methods and really rigorous code writing, the same way you write code for aircrafts or medical software, where the failure of the system results in the loss of life. And then on the academic side, we write papers as if you would be at Harvard or at MIT or any place. We go through the peer review process. Yet, despite that, we are kind of like a startup, so we have to move quickly, and try to balance all of these things at the same time has been the challenge of my career, and we've had a lot of fun trying it.
I can imagine. So Cardano started, and you ended up, we talked about what is a blockchain, but there's different kind of blockchain. We have the proof of work and proof of stake, and then Cardano, of course, is a proof of stake with the Ouroboros protocol. Can you tell us a bit of why you went with the proof of stake and the differences between proof of stake and proof of work?
So whether you're proof of stake or proof of work, you're always trying to do the same three things. Somebody has to be selected to advance the network. Somebody has to then do that. They have to make the block, and then the network has to accept the block. So there's a selection, a production, and a validation, if you want to look at it like a pipeline of things that have to be done. So both proof of work and proof of stake are identical in that respect. The difference is in the selection component. Who gets to make the system? Who gets to make the block for the system? Well, with proof of work, it's a meritocratic lottery. So basically, you mine. It's a process where your computer's crunching numbers, and every one of those numbers is like buying a lottery ticket. It has some numbers on it, and every now and then you find the magic set of numbers, and you've won. You have a golden ticket, and you're allowed to make the block. Okay. Well, that's great, but the problem with that process is that as the value of the asset goes up, the level of competition goes up, which means you have more and more people participating. And then the issue is those people who are participating are consuming a lot of energy in that process. So your energy consumption, it goes way up. And actually, I believe now Bitcoin consumes as much power as Sweden. So that's not a really desirable thing. The other problem is that your cost of participation goes up relative to the amount you can make. So you start seeing economy of scale. So the set of people who do it gets smaller and smaller and smaller and more professional, more vertically integrated. So they're using proprietary patented mining equipment. They're using subsidized power. They're geolocating in areas that have cheap electricity. And so that creates a geographic bias. It creates an economic bias, and it also creates an ecological problem. All right, so mining does a lot of great stuff, but can we do better? So what we started with when we said we had a first principles approach is we said, all right, well, what does mining actually do? What properties does it have? Let's think like academics. So we wrote a paper called GKL 15 back in 2015. And basically what the paper did is it created this idea of what is a blockchain? What properties does it have? And then it showed that proof of work creates a secure blockchain. So that was great because then we had a security target. We had a formal definition of what is a blockchain from a mathematical sense. And then we had a definition that proof of work actually has desirable mathematical properties to it. Then we took all those properties out and we started saying, can we build a protocol that does all those things? However, in the selection process, it has different economic properties. First, the energy consumption goes down, not up. There's an incentive to make it as cheap as possible. Second is the price of the asset goes up, the level of participation increases, not decreases. And third, that the system can be tuned over time to be more egalitarian and fair. So we did that. We wrote almost a dozen papers, and each and every one of them was submitted to different conferences and places of learning. And each step of the way, we formalized and got security proofs. Like, for example, proof of work has a great property called bootstrapping from Genesis. So when you enter a proof of work system, let's say I give you a blockchain and Bob over there gives you a blockchain and Alice gives you a blockchain. You don't have to trust anybody. What you do is you do a calculation. You say, which one of these has the most work? Oh, it's Bob's. Okay, that's the real chain until somebody shows me a chain with more work. So that means you need no prior knowledge of the system to be able to always pick the honest chain inside the system. That's a pretty good property. And usually in the proof of stake world, that's achieved by trusting somebody. You need a checkpoint. Well, we wrote a paper called Ouroboros Genesis, where we actually created a concept that showed that you only need to know what the Genesis block looks like, and you're able to actually figure out which one is the longest chain without a checkpoint. And then we also did stuff about random number generation, clocks, and the synchrony of the network. And so it's a very technical and tremendously involved thing. But each and every one of those basically replicated the properties of proof of work. The difference is that instead of having these computational lottery where you have to buy hardware and crunch numbers until you find that golden ticket to win, you have a synthetic lottery. So let's say you have 25% of the supply. On average, 25% of the time, you get the right to make a block, or you can give that right to somebody else, and that's called delegation. Now, the advantage of a system like this is it's infinitely scalable, and second, power consumption is decoupled from it. Whether your ADA is living on beefy servers or it's living on a Raspberry Pi, you can do the exact same thing and make that block. So you only have to have, for the block making, that second component, a machine that's at the resource rate of the network. And that'll get bigger over time, but it's not connected to some economic process. The other thing is that we have parameters that we can put into the system that when you delegate, because most people delegate because they don't want to make blocks themselves, the set of people you delegate to can grow over time. So it started as a few hundred, now it's a few thousand. As Cardano grows, it'll be tens of thousands, eventually hundreds of thousands, and so forth. What's really cool about that is that means your system's getting more decentralized. Most of these delegators are small businesses, not vertically integrated multi-billion-dollar mining operations in Texas and other places. And the other thing is that's permanent infrastructure that you can use in your system that you can then reuse for lightning channels or random number generation, oracles, or any other types of things. So that heterogeneity actually makes the system far more efficient, especially for network protocols, because you use them as a routing layer to speed up transmission. So you don't have to do these gossip protocols that percolate through. So there's a lot of nuances there, but they're just different philosophies. One is about external control. The other is about internal control. Only people who have ADA can participate in proof of stake. You don't have to have Bitcoin to participate in proof of work. So there's just different control mechanisms, different philosophies, different ideologies. But in terms of security properties of what they end up securing and doing, they're equivalent in that respect. We proved that pretty rigorously, and it's running in a production system worth almost $100 billion at this point. There's probably 150 billion or so of value that's protected by proof of stake. So there's a lot of money at risk. There's a lot of papers and a lot of good code that's been written that demonstrate that these systems scale and they perform well. In terms of energy consumption, Cardano's entire network consumes the power of a warehouse. And as I mentioned, proof of work with Bitcoin consumes the power of a country. So that's incredible that we're able to get better throughput, faster performance, and the power consumption of a building compared to a country. In our view, it's also being a virtual resource much more secure against sovereign attacks. Like China, for example, when they banned mining, there was a big crisis in the hash rate. It went down a lot, and there was a whole bunch of Chinese miners that are trying to relocate all this hardware. With a virtual resource, you relocate your server by just redeploying the software to a different country. So let's say it's illegal in Sweden, but it's legal in Norway. You just simply go from Swedish servers to Norwegian servers and you restart your thing. That's like a day of programming and effort and testing, and you're back in business on Tuesday if it happened on Monday. So I think for a decentralized world, endogenous control makes a lot more sense. And the economic incentives are also directly aligned. Miners don't care about the value of the asset other than how much they're going to sell it for. In proof of stake, you do care, because the only way you can participate is by holding it. The more of it you hold, the more money you have invested inside the system, the less likely you are to mishandle that system.
Yeah. So, but do you see proof of work and proof of stake working together at one point, maybe in the future, in Cardano?
Well, proof of work has a lot of desirable properties that are great for congestion control for transmission of signals, messages, and transactions. Also, you can create hybrid consensus protocols. So you can create a proof of work, proof of stake protocol where some of the blocks are made with proof of work and some of the blocks are made with proof of stake, or some order of that. And we've written some papers, and there's actually been some cryptocurrencies that have tried to do that, like Peercoin in 2011, for example. So that's definitely doable. But I'm not particularly interested in proof of work unless the work is useful, because right now the work is the same again and again and again, and it's optimized, and ASICs are constructed. And there's a huge e-waste problem, and there's a huge environmental problem. If every 18, 24 months you throw away your hardware, then all you're doing is filling landfills with all of this electronic waste. And so my preference would be commoditized hardware like CPUs and GPUs, and then useful proof of work where you're actually solving useful problems. And so instead of building a mining collective, you're building a supercomputer for hire. And it just so happens that also secures a cryptocurrency. And there's been some people who have tried these ideas in the past in a centralized or decentralized way. And we've even written some papers on useful proof of work. So proof of work will go through some upgrades, sharding, useful proof of work, and so forth, and then also hybridization. And that's actually the fourth generation of cryptocurrencies, by the way. So people always ask me, what's after the third generation? The fourth generation is really multiple resource consensus. So instead of having just proof of stake versus proof of work, or proof of history, or proof of space-time, or whatever, you actually combine them together and you create these protocols that use multiple proofs in one. So then no one actor, whether it be a miner or a staker or whatever, is in charge. And then you can use that to actually build a complete decentralized computer, because you can do one for network relay, proof of network. You can do one for file storage, like proof of storage. And there's protocols like Permacoin and whole projects like Shia that are chasing these types of ideas. But combining them all together into one system, I think, is the next generation.
All right. Well, now we're on the technical side here. We know that 12th of September, smart contract is coming to Cardano. What do you think smart contracts mean for the future of Cardano?
Well, it's just one part of the evolution of the program. You need programmability to be useful for all kinds of applications. Not all applications. Like Bitcoin has very limited programmability, but still most popular cryptocurrency. So it's not the key value driver, but it's certainly a major component of value driving. And that's going to enable microfinance. That's going to enable DeFi. That's going to enable oracles and all the kinds of things that we love and see with Ethereum. And there's all kinds of ways that we think we can compete. But that said, it's not the core of the project from its philosophy. The project's philosophy is to improve the systems of the world for everyone everywhere. So the system has to be able to, the protocol has to be able to run a country. So, if you're Ethiopia, you should be able to run at some point your national ID system, your voting system, your property ledger, your settlement clearing system, your stock market, all of these things on a system like Cardano. And you should be able to run it better, faster, cheaper, and more secure than you would run it with centralized offerings. And the people should actually believe that they're credible and be able to use them. Well, smart contracts are part of that story, but they're not the only part of that story. You need digital identity, and that's why we have Prism. And we have 5 million people in Ethiopia who are on it. So we're making some progress there. And we have 110 million to go, right? Then you also need metadata. You need to have layer 2 solutions like state channels and payment channels and these things, so you can do microtransactions. So you have very low cost transactions in the system. And then, of course, you need a really good governance system. So you have predictable, reliable upgrades and changes to the system that are non-disruptive. Because if a nation state's using it, they can't have outages. They can't have Cardano Cash or Cardano Classic, these types of things. So Alonzo's the single biggest upgrade from a utility viewpoint, but it's not necessarily the biggest upgrade from an impact viewpoint. It's just one of many things that we've done throughout the years, and we're here forever. We're going to keep beating the drum and keep growing. And, we've gotten to a critical mass where Cardano is now a swarm instead of a small collection of companies.
Yeah. So all of this is done by a lot of research, and I think that's a different approach to many other projects. They're more hands-on, and they experience their failure, and they might be expensive, and they learn from it and they move on. Why did Cardano choose to go this research path and peer reviews path?
Well, there's two reasons. One is the obvious reason. The other one is the one that, if you really think about it, is the most important. So the obvious reason is knowing it actually works, quality, actually solving the underlying problem. It's kind of a funny thing, but how do you know these protocols actually work? Like, for example, proof of stake. There's a lot of people in the Bitcoin space, maximalists, who say it's perpetual motion, it's a Ponzi scheme, it doesn't work, the rich get richer, all of these things that they levy at you, and they like grinding attacks, nothing at stake, and et cetera, et cetera. Well, if you're legitimately going to address that and be intellectually honest, you have to do your homework. You have to systematically outline all the problems that they brought up and show with proofs in a rigorous way how you've solved those problems before you write a single line of code. Because otherwise what you're doing is it works until it doesn't. And if the protocol fails, look at how much money is in this protocol now. It's in the tens of billions. That could be catastrophic economic loss to people. That's not right. And so the academic process is a tool. It's not the only tool, but it's certainly a powerful tool to get correctness and rightness and just tease out a proper protocol design. And also it engages a lot of brilliant minds along the way. So you end up getting a much more diverse way of doing it, which is a representative sample of the total knowledge of the field instead of the engineer's particular knowledge. The other thing, the non-obvious reason, is what happens when the founders leave. When we look at these protocols, we tend to equate them to somebody. Satoshi to Bitcoin, Charles to Cardano, Vitalik to Ethereum, Dan Larimer to EOS, Macaulay to Algorand, and so forth. Okay, well, you need some mechanism to replace brilliance. You need some mechanism to have scientists be able to come and go, but still produce scientific output. If you already have embraced the peer review system, that's culturally neutral. That's faceless. You can have men, women, Africans, Europeans, Asians, South Americans, North Americans participating, writing papers, and they come, they go, but the papers keep coming. So if you get good at peer review and you build that into the core of the system and the change management part of the system, it means you will always have really brilliant people just in time to solve whatever problems that are there. And those brilliant people aren't connected to a particular culture, ethnicity, language, or economic ideology. Rather, they're there because it's academically interesting, it's scientifically interesting. They just need resources. And because we have a decentralized treasury, which has $1 billion in it, that can certainly provide the resources necessary to get these institutions interested in it. So we also wanted it to basically be a decentralized brain, effectively. So it was an innovation system that could always be able to produce sufficiently complex protocols to solve the problems of the system without me having to be around, or some company like a Microsoft being around to keep pushing that innovation. Otherwise, you have a dictator, or you have a corporate custodian, and that's not decentralized. But if you have a decentralized brain, it is. And you're not over reliant on any one person, and the system can sustain itself. I'm willing to bet that the world's going to be very different 100 years from now. But I'm willing to bet there'll still be universities or educational institutions and academic research going on. So I'll be gone, most likely, or very old and not really connected to the project. And for the most part, the academic world will still be there. And if we're connected to that, that means Cardano will be here in 100 years. That's why we built the system the way we built it and why we were so close to science.
So basically, Cardano is bigger than us, and it will continue after we're left.
That's the point of this protocol. I mean, if it's really going to improve the systems of the world and become the backbone of nation states, it needs to be around in 100 years or 200 years, just like TCP/IP is around. One day, Vint Cerf will die and Bob Kahn will die, but TCP/IP will still be here. The heart of the internet will still be here, and there's a process to change and evolve that. And that was the life's work of Vint for the last 40 years. It wasn't, let's make the internet better. It was, let's build a change management system for the internet, like the Internet Society and these other things. And let's make sure that there's people around who know how to use that. So when I'm gone, that, you know, the system can self-evolve and continue to get better for everyone.
Yeah. So we heard a lot about Cardano in Africa, but we are based in the Nordics here, and we got some question actually in regard to this. So have you have any plans on the Nordic markets? Have you been in talks to any governments, etc.?
You know, I'd love to do something in Norway. I have family in Norway. I'm a quarter Norwegian, and it's a wonderful market. And actually, the Sovereign Wealth Fund of Norway in particular is a very interesting vehicle because the set of investments they have is getting smaller and smaller. They're no longer investing in, you know, petrochemicals and hydrocarbons and you know, things that are contributing to global warming. Well, the problem is they have too much money. They have like 1.5 trillion or something like that of value in the sovereign wealth fund. So it's really hard when you start reducing the set of things you can invest in to successfully deploy that capital and get good returns. So there's a very strong possibility that a larger and larger part of that portfolio will be things related to our industry and related to developing economies that as social benefits. So they call it impact investing or social capital or these types of things. So it'd be really fun to see if we could do a deal with them. Also, we're very interested in a lot of things like carbon credits and other such things. And this has always been a big part of Scandinavian life. And it would be interesting to see if we could do a carbon credit system somewhere in Scandinavia. We're right now testing something in Wyoming with several partners there. And you know, Norway still produces oil, and they're still involved in this this industry. So that'd be a lot of fun. But generally, any government or any society can adopt this, and there's entrepreneurs everywhere. And we have actually a fairly strong Norwegian and Finnish and Danish Cardano community. And the head of the Cardano Foundation is Danish, you know, Fred Gregard. So we're always looking north from time to time, and we're always looking for cool business there. So when COVID recedes a bit, I'm definitely going to go back, if anything, just to go to Tromsø, because I love riding, you know, doing dog sledding up there and hanging out with the Sami people. But we have plans as a company to pursue that marketplace. Now, relative to other marketplaces, you know, Africa is always the heart of the company. We've been pushing very aggressively there. But you know, I would definitely do business in Norway over France, for example. You know, 10 out of 10 times. I like France.
Well,
it's a beautiful place. It's not a very friendly business environment.
But what in which areas do you think Cardano would have the greatest impact here in the Scandinavian countries?
I think in governance in particular, you know, you can apply this system at some point to run the elections of nation states. And when you start thinking about the new citizen, the next generation citizen, you have layers there. You have like digital identity, you have the wallet layer. And then once you have those two things wired in that work on your cell phone, then you can start talking about, well, I, at any given time, can send to every citizen in my country a poll. So if a world leader is trying to think about something like, you know, should we have the parade on Tuesday or Thursday for, you know, our victory in the Olympics? And you just send a poll to all your citizens. They get a little push message and say Tuesday, Thursday. Oh, Thursday. Okay, 62% said Thursday. That's what we're going to do. But then you can also use that for any question that you have. Should we go to war or not? You know, these types of things. And only people can vote are verified citizens. The cost of doing that is zero. It's literally just phrasing the question and pushing it to the phone. verified users do that. The same for universal basic income. If you want to send subsidies to your people or incentives to your people, once you have the wallet infrastructure on a person's phone, you can send to a Norwegian or a Dane or anyone that payout, and it's just there every month. You can do also dividends from a sovereign wealth fund if you wanted to do that. So that's another option. So if every quarter you wanted to get a payout from it, you just send it to their phone, and there's almost no cost or friction. The same for issuance of bonds. So if you want to issue debt to diaspora, very common in the developing world, or diaspora-centric countries like Greece or the Philippines. In Greece, there's more people living out of the country than in the country. They have a very large set. So if the Greek government was to issue bonds, it would be very easy for them to do that and send it to Greeks only who are abroad and registered in the system, and do a primary offering to them. And that could raise billions of euro in value. So any of these things can be tremendously useful also for audit, transparency, and oversight. So the same things that you can do to keep a supply chain honest, you can do to keep a government honest. Wouldn't it be nice to live in a world where you get a report card that shows you what your government's spending money on, and you can track and trace all of that, and you know that there's honesty inside that type of a system? I mean, just look at all the infrastructural development in Norway. They're building highways and all these other things. Like, where is all that money really going? And they say 40 billion euro to go and build something. There's something more to that. So in America, we have a tremendous problem with government abuse and waste, especially in the military. That we spend almost $1 trillion every year on this war machine, and the Pentagon just loses money. It's like, where did that $25 billion go? We just can't find it. Sorry. So it would be nice to have systems that enforce auditability and oversight in the very same mechanisms that can verify a vote, verify that your Bitcoin hasn't been double spent, can also be reapplied to other domains. So this is the fun part of my job. You see, I'm not a domain expert in the politics and the problems of Norway, for example. But what I can do is I can talk to them and say, what keeps you up at night? And then we can offer a digital transformation service that not only solves that problem, it solves it with an open source, open access framework. So there's no vendor lock-in, there's no patents, there's no intellectual property, and it becomes as much the property of the Norwegian people as it does to the entire world. And the Norwegian people have assurances that even their government can't manipulate this system after it's deployed for political purposes one way or the other. So there's an honesty about that transcends politics, and that hopefully will improve institutional trust and remove cynicism. That's our biggest issue right now in politics, is people don't trust institutions anymore, and everybody's very cynical, and everybody thinks governments are bad. Well, once you start installing these types of systems, even the government can't lie to you, and its behavior is as constrained as yours. So it resets and changes the relationships in that respect, and that's a really fun social experiment to explore.
Mm. So we've asked the community on Twitter, Facebook, and Discord for some questions, and I thought we'll try to end the interview here with some questions. So I picked out a few that are in line with what we are talking about, and in line with what we are allowed to talk about when it comes to non-price speculation, because people really ask questions about the price. So one good question that I found was that was this guy who asked that he thinks that crypto is just speculation. It's just winner takes it all, or a pyramid scheme. Like, he would like to hear about some sort of example where crypto actually makes a difference, like a use case, like a real one that's happening right now.
Sure. There's plenty of projects where people are running remittances and microfinance using cryptocurrencies, especially in the combination of a stable coin. And these aren't academic concerns. I mean, if you look at remittances, so that's where poor people living abroad send money home to their parents or their family. In a lot of remittance countries, they have to pay 15% or more to move value home. So, let's imagine that you're a maid in Oslo and you work really hard, and every month you send $100 of value back to Senegal. Well, on average, by the time that hits your parents, your family, your friends, they might only get $80 of actual value, if that. So these are the poorest people in the world, and the system is taking usurious transaction fees. A cryptocurrency, they can just tap a button. It goes from one cell phone to another cell phone, zero transaction fee, or extremely low. We've never had technology before like that that allows the trustless push of value from one system to another system. The identity components of cryptocurrencies. How do you build a national ID system that's truly global and you're in control of your identity and your data? We have this huge problem right now. There's a beautiful book called Surveillance Capitalism, and it talks about how pervasive data mining is amongst these big tech companies like Facebook and other people. But basically, you're the product. So how do you own your own identity and you own your own data? Well, in Europe, we have GDPR, but that's not universal and ubiquitous, and it has a lot of holes in its design. And the minute that you step into America or go to another country, it's over. You don't enjoy those protections anymore. Well, what if you had a digital identity system and a data management system that actually is connected to you, not a Fortune 500 company, and you're in control of sharing policies? So I'll give you a great practical example where this is happening real life right now. So there's a venture over in Silicon Valley called Nebula. It was started by George Church and a bunch of other guys who were connected to the Human Genome Project. So Nebula basically will sequence your entire genome for a few $100s. It used to cost billions of dollars to sequence the entire human genome, but they can do it for a few $100s now because of technological improvements. Well, what's the difference between them and Ancestry and 23andMe? Well, Ancestry and 23andMe, when you get your DNA sequence, they own it and they can share it. The pharmaceutical companies, the government, other actors, and so forth. With Nebula, you own it, and your access control is controlled by a blockchain system called Oasis Labs. So basically, you're in control of your DNA and you're in control of the sharing policy of such a thing. Don't you think that's going to be a bigger problem over time, especially with insurance companies doing genetic discrimination? They say, oh, we noticed that you have a certain gene for cancer in your genome, so we're going to charge you 30% more for insurance. How did they find out? You did a 23andMe test and it was sold to them. You see, so these are real life examples of where your privacy, your identity, the movement of value, the current systems are very problematic. And the point of these protocols is to do this for everybody. So they're open. And why do they have to have a token? Well, how do you pay to maintain them? You need some sort of infrastructure that allows the system to reach consensus, to control the flow of transactions and price those transactions, and to create incentives for the maintenance and growth of the system. So by having a token attached to it, that allows the system to become global. No one would care about Bitcoin if Bitcoin didn't have value. We had those days, 2009, 2010. Bitcoin was worthless. How many people talked about it? The technology is mostly unchanged. But because Bitcoin's valuable, everybody talks about it. Because everybody talks about it, there are thousands of companies building on it, producing things and growing it, and so forth. So it's a combination of solutions to problems that we couldn't solve before in satisfactory ways, and economic incentives to bring people to pay attention to those problems and think about them. Same for the internet. The internet got good when people realized they could get rich. And that's what brought us the Googles and the Facebooks and the YouTubes and these companies to come and start and get it done. The same for Amazon and so forth. If everything was volunteer and free and there was no equity value appreciation in the internet with these startups, there would be no startups. And the internet would be like the internet of the 1980s. It would be wired to universities and libraries and these things. And it would just be mostly for the movement of information, but you'd have no consumer experiences in that respect. So real systems need a combination of all those things. They need revolutionary solutions to problems. Other things like medical record movement. That's a huge problem. I travel all around the world, and I always think to myself, God, when I'm in Africa, what if I get hit by a bus in Ethiopia? And I'm unconscious and they take me to the hospital? How does the doctor in Addis Ababa get my medical records from Colorado? That's an unsolved problem that no one in the world right now has a solution. The only system that can solve that problem would be a blockchain-based solution. And there are dozens of medical record blockchain companies right now trying to solve that, right? And doing experiments in some cases with nation states in their national medical record system.
That's super interesting. So we're running out of time here, and I thought I'll ask you this this last question, and that is, how do you see the future, and what's your dream scenario within this space?
I'd like to live in a world where the systems of the world are equally fair for the least amongst us as they are the strongest amongst us. That's a very basic principle, but I think it's the only way to move forward with progress. We accept for some reason that it's okay that billions of people, because they lost the geographic lottery, they were born in the wrong country, don't do so well. and that we have, for the first time in human history, the ability to solve that problem. I'd like to live in a world without kings or presidents or CEOs or leaders. Instead, power comes from the bottom up. We just basically come together when a problem occurs and figure out as a collective how we're going to solve it and get it done. I'd like to live in a world where we have faith in our institutions and we think those institutions are credible and reliable, instead of a world where we think the institutions are corrupt and bureaucratic and ineffective, and in some cases adversarial to us. And also, I'd like to live in a world with peace that can solve existential problems. And we have a lot of existential problems on the horizon. 20th century, when my dad was growing up, it was nuclear weapons. That was the big problem. That was the only one that could end the human race. Now we have global warming and the event of synthetic biology and all the designer organisms that's going to create. You have nanotechnology. You have the rise of AI. You have dozens of these existential problems. And the problem is that they're now in the hands of private industry. They're in the hands of small-scale research institutions. One research group can create a virus that could kill half of humanity. And we've even actually stumbled upon this with gain-of-function research with avian flu. About a decade ago, they published a paper. They said, hey, we found a way to make avian flu human transmissible. This is a disease with a mortality rate about 30 to 50%. COVID is, a best case scenario around 3% for the elderly, about 0.3 on average. And look what it did to the world. Could you imagine a disease that's 10 times more deadly? And a small group of scientists were able to do that themselves. So if we do nothing, the default path is disaster and catastrophe and total totalitarianism and dictatorial control. We already see the data surveillance in China with social credit. That's going to become the de facto standard. And the point of this technology is it's the third option between anarchy and chaos or total government control. It's a way for us to be in control of our own lives in a certain respect. And what's so beautiful about it is it's open. Every single person, whoever they are, wherever they come from, in their own way can participate. Look at the NFT revolution. Artists are now here making buku money and doing cool and interesting things. This was supposed to be for like crypto nerds and cryptographers and mathematicians. And so many people, they barely can turn on a computer or going and issuing NFTs and selling things. You got 60-year-old musicians that are coming in, 70-year-old musicians that are coming in selling things. So that's the beauty of this, is that this is not just one thing, it's everything, and it's everybody's movement. And I'd like to live in a world where everybody can make it their own and contribute their own way. And hopefully we can get out of all the problems that are on the horizon.
That sounds like a nice future.
Better than the one we're headed towards.
Oh yeah, that's right. Well, I think we need to end it here, Charles. It's been an interesting hour with you, and we have tons more to talk about. We have so many questions from the community, so we would have to schedule another hour to get through that. So I hope we can do this another time with the Nordic community. So I would like to thank you for this.
Thank you so much. Hopefully next time we can do this in Norway.
Yeah, you're welcome. Anytime. Just give us a call, yeah?
Yeah. All right. Thank you so much. Yeah. Cheers.
Take care, Charles.